And I thought, man, this looks easy. So what we're going to start with, 1,6-diphosphate. There's 2 phosphates on a fructose. This is after the glucose has been manipulated around. Get to a 1,6-diphosphate. It splits. This is where the chemistry comes in. Glyceraldehyde, 3-phosphate. So let's start with drawing glyceraldehyde, 3-phosphate. There's only 3 carbons to this. The phosphates are going to be the confusing part. So the first thing we're going to draw is just 3 diamonds. 1, 2, 3. 3 diamonds. Aldehyde, double bond on the end, right? Diamond ring there. Getting a little intimidated, all right, take a break. 1, 2, 3, there's 4 bonds on that. Take a second, color it in. There's only 3 carbons to do, and you know what? There's one of them. 1 down, 2 to go. Oxygen's done, right? Color that in. It's got 2 bonds on it, so it gets all the way in. Always overcolor the green because there's a lot of negative charge around oxygen. There's 2 lone pairs of electrons out there. Remember our 2-headed alien? Okay, the next carbon coming down has an alcohol group on it. Now there's some stereochemistry to this, but the book we're drawn to is just going to have a flat structure here. So here's O. Alcohol gets a dot in the middle, right? Ooh, I'm getting a little intimidated. Let's take a break. We'll color that one in. It's got 4 bonds on that carbon. That's all it needs. Carbon to carbon, hydrogen on there, and an OH. So we'll color that in. You can go over again. It's still got 2 lone pairs of electrons on there. Now, the 3rd carbon. This is going to go to a phosphate. Are we afraid of phosphates? Not at all. To save space, we're going to draw this sideways. So the phosphate gets connected by an O. Should probably be that one down there, but tough. Five-membered ring for a phosphate. Gets a double bonded O, so let's get that out of the way. I'm getting a little intimidated. We can back up, look at our structure here. We see there's 2 hydrogens. Let's color that in. Okay, so look now. Now we're done with the 3 carbons. Now we got to take care of the 5-membered star. Well, we got an oxygen here. Let's color that in. Color some of this into Emmylou Harris, Kentucky Sweetheart. Lexington, 1977. Now we're getting oxygens on these, right? The PO4, there's 4 oxygens on a phosphate. So in this case, this O is going to be an alcohol. And one of them they usually draw as being uncharged. So we don't even need the lines on there anymore. We're getting to be such proficient chemists here. So let's see here. O. Now how are we going to do a negative on there? It's got a negative charge to it. Only one of these gets protonated at normal biological pH, they call it. So we're not afraid of phosphates, huh? One's going to be an alcohol. One's going to be an O to the carbon, one's going to be O with a negative, and one gets double bond. That's the easy one, right? So see, now we're stepping up. We're getting more sophisticated in our chemistry here. 5 bonds. Even Emma Lou says it's going to be easy from now on. So now we're introducing new colors, huh, kids? You thought it was all getting boring before. Color in phosphorus. Orange star. Our star is considered yellow-white, but we get so much in the visible that we can't really see the yellowish part of it. So there you go. Glyceraldehyde. Aldehyde is up here. Glycer is 3. 3 phosphate because you count the carbons. 1, 2, 3. The phosphate is on the third. That doesn't mean 3 phosphates. This probably confuses a lot of kids. So the next reaction is they're going to throw another phosphate in here. This was what I was talking about before when the oxygen with all the electrons pulling on it. Remember, that's a 2-headed little alien there, right? That's pulling all the electron density of that carbon to that side. So they'll draw a little plus there, a little delta plus, they'll call it. So now when another phosphorus comes in, this part here with the negative, that's what we should have drawn. We should have just drawn this is a 3-headed alien. Okay, if you're afraid of aliens, you're not going to like this oxygen. So the next molecule that comes up in this, after it gets phosphorylated, it's called a phosphoryl group. It's not a phosphate. Because technically this O is considered part of that carbon, but so now we're going to end up with a